we talked about total derivative. Now let us see what geometrically it means. Okay, so let us first see. Suppose you are having z. Let z equal to f of xy be a function. And first of all, let us see what is geometrical interpretation of partial derivative. It is tangent, na? Geometrical interpretation of partial derivative is the slope of tangent to the curve represented by the function at that point. Okay, so what does partial derivative represent? It represents slope of tangent at that point. Okay, in particular, if you talk about, that is, in particular, if you say dou f by dou x at eb, so what do you mean by that? This corresponds to the curve represented by z equal to f of xb, which is obtained by this z equal to f of xb. This is obtained by intersection of function and the plane y equal to b. Okay, which is obtained by, you can write that, which is obtained by intersection of z equal to f of xy and y equal to b. Okay, so this is uh, dou f by dou x at eb. And what about, so what do we say? That is dou f by dou xi at eb represent the slope of tangent to this curve at x equal to a. Correct, with respect to x if you are doing. Okay, so what do we mean by total derivative? What is f of e plus h? Already you know f of e plus h, that is f of e plus h into f dash of e. Correct, so what is f of e plus h? Minus f of a, that is h into f dash of a, and f dash of a is your total derivative actually. Correct, so it represents that with the change of values of e plus n, that is their subtraction, that is equal to h into f dash of a. Okay, so let us try to see the graph first. Suppose you are having this function. This is a three-dimensional plane. That is now you are having z equal to f of x. So it will be a diagram, that is, see, z equal to f of x having this figure. See, this is your function. See, I'm talking about, it is something like a shade, something like, you can say, tent, where this is a pool and this is a like a cloth, something like that, correct? And inside there is this is my base and this is my cloth, so you should understand that. Say here this is point x equal to a, and say here you are having y equal to b. Okay, so maybe I'll just put y equal to b here. So draw that. So this is x equal to a, this is x equal to a, this is y equal to b. Okay, so what will be this point if you just plot this on the surface? So on the surface it will be somewhere something like this actually. Same at this point if I want to plot something like this. So again it will be something like, and if this point is on here, correct? So what is the coordinate of this point? Coordinate will be e b f of a b. This is the coordinate of the point. So I want to calculate the derivative at this point, correct? So what will be my partial derivative here? T1 will be along x-axis and T2 will be along y-axis, something like that. See, it is actually parallel to y-axis. This guy is parallel to it. Doesn't actually look like that. Maybe I'll try to make that. It is something like parallel to y-axis. Yeah. So first of all, understand the function z equal to f of xy. This is something like um, this is something like a tent where this is my pool, and you are having this as a this may be क्या बोलते हैं उसको, this may be like a shed also, but now I am here taking it on the ground. So something in general you can take any function. So this is what my function, and I talked about this point, how to get that point. So यहाँ पे x equal to a, this is y equal to b, and the point will be e b f of e b. Okay, now let us see what will be my derivative. How will you calculate derivative? Okay, so to calculate derivative, yeah, this is done in one variable, that is scalar valued function. This is okay. If you are having two variable, that is in case of two variable, let us say point x comma y equal to e comma b, so that so the corresponding point on the surface, it will be corresponding points on surface, it will be a comma b comma f of ab, which I just now showed it to you, correct? Now when we make small changes in eb to say a plus h comma b plus k, then the corresponding change in surfaces, that is this f of e plus h comma b plus k minus f of e plus e comma b. So this is your corresponding change in surface. If you make small change in the point e b, e plus h, you're considering e plus h and b plus k, so this is your corresponding change. Okay, we'll draw that. Let us just first see. Now to find this approximate value, to find its value, we approximate the surface by means of tangent plane. By means of tangent plane to the surface. At which point? E B f of E B. So I have to get the tangent plane at this point. Correct? And the equation of tangent, you know how to calculate equation of tangent. tangent at EB f of EB is given by, you know the formula, z minus z naught. So z naught is z minus f of EB, that is equal to fx into x minus a, fx into x minus a. Fx I am talking about at EB, and this will be fy, this is fy into y minus b, correct? Yeah. So if you solve it little bit, what is your z? Z is your function x. This is f of x comma y minus f of EB, that is equal to fx into x minus e and plus fy into y minus b, correct? Now let us substitute something. What I want is, from here I got the value of this in terms of fx and fy. Can I what was my aim? My aim was to estimate this thing. So what I have to substitute? I have to substitute x equal to e plus h and y equal to b plus k. If I substitute, what will I get? That is f of e plus h comma b plus k minus f of eb. That will be equal to what? That will be c x minus e, मतलब क्या आएगा? That is h. So it is h into fx, fx at that point. eb अगर लिखा, यहाँ पे भी fx at eb लिखना चाहिए था, और just let me write as it is, h into fx plus k into fy, correct? And we are talking about eb. So what did you get? That means what? The total derivative is what? Yes, total derivative, that is dz by dt, that is equal to df by dx, dx by dt plus df by dy, dy by dt, and which you can clearly see. What is fx? This is your fx, dx by dt, that will be h, correct? And this is df by dt, that is k into that. So what will be your total derivative if you want to write? Then total derivative is just say dz, that is equal to fx dx plus fy dy. That measures the change, correct? Dz means what? I want to take the difference. I want to take this difference, correct? Either you write this one or you write this one. Now let us see graphically what did I do. So we are having a three-dimensional diagram. Something like this. So this is x-axis, this is y-axis, this is z-axis, correct? So on axis is, suppose I am having a point E comma B. So this is say point A, this is say point B. So E plus H will be somewhere here and B plus K will be somewhere here, correct? This is B plus K, this will be your E plus H. So the point EB will be here and f of E plus, so it will just form a rectangle actually, something like this. Okay, and what is this point? This is your E comma B, and what is this point? This is your E plus H comma B plus K. Now what I have to see? I have to see image of this on the function. Suppose my curve is this. You can take any your function. Say this is my function. Okay. Or maybe thoda sa. See, I just want to calculate the values. See, this is my function. Okay. So what I have to do? I'll just take the image of EB here. It will be here. Correct. and you will see there will be a rectangle forming here. That is corresponding points, you can say. Okay. Mhm. It is something I'm forming a pole, you can say. I'm sorry for the bad diagram. Yeah. So this is what you are having. Now if you quickly mark the point, so this will be the point. This will be EB, and F of EB. And what will be this point? This will be E plus H, B plus K, and F of E plus H comma B plus K, correct? So this is image of the function. Now what you have to see, you have to see the subtraction, that is uh, this point minus this point, their subtraction, that will be now you observe one thing, that it need not be always a rectangle form. It is something like if you are having chips, so do you see how it used to be? It used to be something like this. Somewhere it is never straight. If you see some chips like that, correct? So it is something like that. I am drawing a rectangle, but it need not be rectangle. There may be the points which are on the surface, and it depends on your function all the time, correct? So same thing what I have drawn here, यहाँ पे क्या किया था मैंने? I drawn everything on this function, that is EBF of EB, that is EB, and now here see, I am taking this. Okay, so what is their subtraction? From this I am seeing that their subtraction is H into Fx plus K into Fy, and you need to know that what is Fx and Fy, which I already told you. Fx and Fy are the tangent vector along x-axis, and this is along y-axis. Okay, so what will be my total derivative? You can say total derivative is product of your gradient vector, that is delta f into h into k. H into k is the distance. See, this is the distance k, and this is the distance h. Okay, this is just dot product of these two people, gradient vector and that h into k. Okay, yeah. Now let us see we had done with one theorem. Now let us give some counter examples. That is, first let us give, if f is differentiable at E, it need not imply fx and fy are continuous. So let us give a function which should be differentiable at that point, but fx and fy are not continuous at that point. Okay, so let us see. Suppose I am having this as a function, f of xy is this, x square plus y square into sine of 1 upon root of x square plus y square. Now go back to your unit 1, if you remember how to find, unit 2 I think, how to find the derivative. This is 0 when your value is 0, x comma y is 0, and here when your value of x comma y is non-zero. Okay, so this is your function. First thing, you have to check whether it is differentiable at A. How will you do that, whether it is differentiable? You just start with epsilon delta definition. You know the estimate for sine, you are having this, so it is definitely uh, differentiable, or you can quickly check by using total derivative. Okay, or if you want to find total derivative, then one more easy method is, that is t of hk. It will be of delta f at that point, say at 0 0, into hk. So now to find total derivative, you just have to find delta f at 0 0. That is fx into h plus fy into k. Correct? So let us quickly find fx and fy at 0 0. Correct? Now you see that this is a function where you want to find fx. So it is good to use the definition. Do you remember what is definition of fx? Fx at 0 0, that is limit h tending to 0, it will be f of h comma 0 minus f of 0 0 upon h. So let us put it in the function h comma 0. If you put, so it will be h square sine 1 upon h. So it will be what? Limit h tending to 0, this will be h square sine 1 upon h. Correct? So h getting cancelled, you will be having limit h tending to 0 h into sine 1 upon h. What can you say about this? Yes, sine is always lying between -1 and 1. If you multiply both the side by h, then this limit will be 0. Do you understand that? Sandwich theorem. You cannot use any L'Hopital rule or anything here. The one thing you can use is sandwich theorem. Okay, so fx is 0. What about fy? Fy at 0 0, what is the formula? That is limit k tending to 0 f of 0 comma k minus f of 0 0 and divide by k. Let us quickly do that. So here also I think the same thing will be there. That is k square sine 1 by k upon k, and that is, yeah, that is 0. So both you are having fx and fy. So what will be my total derivative? That is t of hk, that is equal to delta f at 0 0 into hk. That is definitely 0. So it is differentiable definitely. So you got that derivative exist. Correct? And see, total derivative मिल गया, तो if you want to prove differentiable, then you can put it in the formula. That is, what is the derivative formula? Limit h comma k tending to 0 0. We are having f of 0 0 plus sorry, f of 0 plus h comma 0 plus k minus f of 0 0 minus t of hk. Correct? This is the definition. And divide by norm of hk, that is square root of h square plus k square. Just check whether this limit exists or not, and this definitely exists. What is this? This is limit hk tending to 0 0. और you can directly say यहाँ पे total derivative मिल गया, that means differentiable तो है ही. You'll be having h square plus k square and multiply by sine of 1 upon root of h square plus k square, and everything is 0. This is also 0, this is also 0. Divide by root of h square plus k square. Correct? And how will you do that? That is limit h comma k tending to 0 0. You are having root of h square plus k square multiply by 1 upon root of sine. Sorry, it will be sine of 1 upon root of h square plus k square. Again the same thing. You know that sine is a bounded function between -1 and n. Just multiply with this thing. You are having limit as 0. So what it implies that f is differentiable at this point at 0 0. Correct? But what was my counter example? I wanted to prove something, that is, I'll start with f is differentiable at that point, but fx and fy are not continuous at a. This is what I want to prove. Correct? So let us find now fx. Now see, do not confuse with fx at 0 0, that is 0. So can I say whether it is continuous? No, it is not depend on x. So अगर तुमको fx निकालना है, तो you can use the original definition of fx. See, what is f of xy? That is x square plus y square into sine of 1 upon root of x square plus y square. So what will be my fx? Now you can do it from here because you want to find it in terms of x. So you have to apply u into v rule. That is x square, it will be 2x into this will be as it is sine 1 upon root of x square plus y square, and plus this will be as it is, that is x square plus y square sign will be cos 1 upon root of x square plus y square into derivative of 1 upon root of x square, that is derivative of 1 upon root is 1 upon 2 root. So it will be root मतलब by 3 by 2 minus 3 by 2 होगा. So it will be 2 times x square plus y square raised to 3 by 2 and derivative of inside, that is 2x. Correct. And there will be minus sign because minus 3 by 2 आएगा. Correct. And into x raised to n minus 1. Yeah. So this is multiplication. Huh? So once you are having, you just solve it little bit. That is 2x sine 1 upon root of x square plus y square minus x upon root of x square plus y square into cos 1 upon root of x square plus y square. Now what you have to say, you have to check whether this function at 0 exists. So look at this. Look at dou f, that is fx at x comma 0. Look at fx at x comma 0. What do you see? That is, I'm putting y 0. So what do you see? This will be what? 2x sine 1 upon mod x minus this will be x upon mod x into cos 1 upon mod x. Correct? This is what you are having, fx. But do you see what is this x upon mod x? If your x is positive, then this will be 1. If your x is negative, then this will be minus 1. So this will oscillate. So which oscillates between 1 and minus 1 due to cos term near origin. So this oscillate between 1 and minus 1. What do you mean by that? What can you see now? Correct? It won't be continuous in that neighborhood, na? Because limit different are hai. If you are going x from positive side, it is giving me something else. If I am going from x from negative side, it is giving me something else. Correct? So limit is different. So similarly for fy you can check. Fy में क्या रहेगा? Here you will be having 2y and that's it. Sine cos. Same thing, just little bit changes will be there. So similarly, so thus what can you see that implies fx is not continuous in any neighborhood of 0 0. Do you see? Because I took the neighborhood where x I keep as it is, y को 0 put किया, then I am getting this. So which oscillates between 1 and minus 1. So there is the issue. It is fx is not continuous at this neighborhood. Similarly for fy. Correct. So what did you prove? Thus continuous partial derivative implies differentiability, but converse is not right. No, but differentiability does not imply continuous partial derivative. You must understand that. ये हम लोगों ने प्रूफ किया, that is if you are having continuous partial derivative then the function is differentiable but not converse. That is, if it is differentiable, I cannot see that it will have continuous partial derivative. You must understand this. Okay.